We present VoicePilot, harnessing LLMs as speech interfaces for physically assistive robots. Physically assistive robots can enable individuals with impairments to perform a range of self-care and household tasks, which can help increase their independence and well-being. An LLM-based speech interface can allow a user to provide personalized instructions to an assistive robot, such as the OB feeding robot, much like they would to a human caregiver. In this work, we present an iteratively constructed framework for integrating LLMs as assistive speech interfaces for a robot. Next, we integrate an existing LLM with a commercial feeding robot using this framework and evaluate the interface through a human study with 11 older adults from an independent living facility. Lastly, we present a reflection and design guidelines based on the findings of the human study. The final framework was iteratively obtained through the implementation and testing of 3 different versions. The first version was created from existing literature in the field. In order to iterate and evaluate on this framework, we designed a speech interface using GPT 3.5 Turbo from OpenAI for the OB, an assistive feeding robot. This interface was then used to evaluate the framework through pilot studies with lab members. The second iteration focused on improving the accuracy and consistency of the interface, and changes were demonstrated with members of the community at a local disability awareness event. The final iteration focused on increasing ease of use of the system and was evaluated based on a formal study discussed later in this video. Our framework consists of 9 components: environment description, robot functions, function applications, code specifications, safety, robot variables, instructional materials, user control functions, and feedback. Next, we conduct a formal study with 11 able-bodied older adults at an independent living facility. Participants were asked to complete 5 predefined tasks and a 7-minute-long open feeding session. One such predefined task was to scrape yogurt from a bowl and feed yourself.
Obi, scrape down the yogurt dish and give me a spoon.
Hey Obi, scrape down the sides of the yogurt and give me a scoop.
Hey Obi, scrape down the sides of the yogurt bowl and then feed me a scoop of yogurt.
Hey Obi, scoop the side of the yogurt bowl and give me a spoonful.
As seen, our LLM interface allowed participants to use vastly different phrasings while still resulting in the same robot action. We used this study to validate our framework and find that participants reported low workload measures and strong Likert ratings on ease of use and learning curve. Participants tried to command OB in several creative ways during the open feeding session.
Hey Obi, feed me a scoop of blueberry and yogurt combined.
Lastly, we conducted a thematic analysis on qualitative data obtained during the study to gain insights into the needs and challenges that our participants faced when using the interface. We present these as design guidelines for LLM-based speech interfaces. First, interfaces should offer customization options, specifically the ability to execute non-predefined commands and modifiers to predefined commands. Second, interfaces should be capable of executing multiple functions sequentially from a single user command. Third, interfaces should consistently execute commands with the same LLM output for differently worded and repeated command phrasings. Fourth, interfaces should execute commands with speeds comparable to a caregiver, ensuring reasonable and personalizable execution times. And fifth, interfaces should have the ability to socially engage with the user during execution of the physically assistive task to more closely mimic the role of a caregiver. In summary, we present an iteratively constructed framework for integrating LLMs as assistive speech interfaces for a robot, create and evaluate a speech interface for a commercially available feeding robot using this framework, and propose design guidelines based on reflections from the study. We urge researchers to adopt these guidelines and framework when integrating LLMs into speech interfaces for physically assistive robots.